Welcome to this video on architecting the data engine. Today, we're exploring the anatomy and strategic deployment of SQL Stored Procedures, a vital component for professional database management. Relying on raw, ad hoc SQL queries often leads to chaos. Issues like code duplication, increased development time, higher maintenance costs, and a greater risk of errors can quickly compromise your database infrastructure. The solution is the procedure pipeline. A stored procedure is a pre-compiled collection of SQL statements and procedural logic. Think of it as building an engine once and triggering it whenever you need it. Stored procedures offer a pre-compilation advantage. By parsing, optimizing, and compiling logic beforehand, they enable faster execution and significantly reduced CPU usage compared to standard repetitive queries. Beyond performance, stored procedures act as a security shield. They allow for granular permissions, enabling users to execute specific tasks without granting direct access to sensitive underlying data tables. When we look at the anatomy of a stored procedure, we see a structured system comprising parameters, variables, core SQL statements, conditional logic, loops, and return values, all working in unison. The data manifold uses input parameters to inject flexibility into your procedures, allowing the same logic to process different targets, while output parameters efficiently return results back to the caller. Internally, components like variables, if statements, while loops, and exception handling allow you to build robust, complex logic that can reliably handle runtime errors without breaking the system. There are different types of procedures: system procedures for management, user-defined procedures for business logic, temporary procedures for session-specific tasks, and legacy extended procedures. It's important to distinguish between procedures and functions. Procedures offer higher complexity and support data modification, whereas functions typically return a single value and are often used for read-only calculations. Every architecture involves trade-offs. While stored procedures provide improved performance and centralized maintenance, you must also consider potential downsides like vendor lock-in and more complex version control. In practice, executing a stored procedure is seamless. A single command triggers the internal engine, allowing for secure updates without exposing your underlying tables to the client application. These engines power enterprise systems across various domains, including banking, e-commerce, healthcare, and human resources, acting as a secure central nervous system for complex organizations. When implementing, follow these best practices. Use meaningful names, maintain modular focus, validate inputs, handle exceptions, and ensure thorough testing and version control to maintain high standards. Ultimately, stored procedures remain an indispensable data asset. They provide the efficiency, scalability, and security that modern organizations demand, cementing their role as a foundational architectural pillar.